Hello and welcome to the Lucas-Nuelle webinar weeks. Today we're having a look at Industry 4.0. My name's Daniel. I'm here with my friend and colleague Marijan.
Hello everybody, and also dobar dan to Croatia. Hello.
Dobar dan. Had lots of people signing in all week from Croatia, so it's great to see you all. And from people literally from all around the world as well, so thanks for signing in. So Marijan, Head of Automation, Product Manager. We're here with your beautiful Industry 4.0 system. Quite a sight to see. Mm-hmm. So interested to have a look at what you've got for us today.
Yeah, you will see it in the video.
Absolutely. Yeah. So today we're going to have a look at the app in a little bit more detail in the video.
Yes.
Yeah. Industry 4.0, so it's obviously the big term everyone's been talking about the last few years now. Smart factory, it's kind of the Internet of Things has brought it into the industry, into manufacturing. In a lot of the trips that I do to the US, for example, people are talking about how they're building new factories for, especially the automotive manufacturers. They're actually having trouble finding the people to work on the systems.
The specialists.
Absolutely.
Yeah.
So how do you think something like this is aimed at people working inside those factories?
Yes, absolutely. So because what you see here, our smart factory, our Industry 4.0 production line is a small production line because it's for trainees, to learn how to program it. But what we use here are industrial components. So like in the real industry.
The protocols, the programming languages are all the same.
Exactly, all the same.
So
the only difference is it is a little bit smaller. Yeah.
And you've been to colleges, I'm sure, around the world as well, where you've seen, and they've got complete conveyor systems.
Yeah.
And it doesn't really make sense to have something like that inside a classroom.
Yeah.
So it's really bringing it down. The principles are always the same. And I think that's a general Lucas-Nuelle philosophy, is really about understanding, even at the fundamental level, giving the students an idea of what they're going to see when they hit the real life.
Yeah. Correct.
Yeah. Mm-hmm. Okay, so the app is what we're going to look at today.
Yep.
That's a pretty new thing that you've developed here as well.
Yes. So the app, the augmented reality app, is the new product we have here, and you will see it at the end of the video. And after the video, then we can talk also a little bit more about the app, and I can explain how it works together with the hardware, and this we will see. And yeah.
Okay. Just a couple of things before we go there, because just in case not everyone's super technical, there's a couple of things we talked about. ERP, MES, they're particular to Industry 4.0, right?
Correct.
Maybe you could just tell us a little bit about ERP, MES, before we see that in the video.
Yes. The production line has PLCs inside, and the PLCs communicates together. But if you have only PLCs in your system and maybe also a SCADA system inside, then you have Industry 3.0. What we did is that we add two higher levels to the machine, the MES and the ERP system. So the enterprise resource planning and also the manufacturing execution system. And to have the MES, the manufacturing execution system, is a must to connect the ERP system with the hardware. So the MES is the connection between ERP and hardware. And if you connect everything together, the hardware up to the ERP, then you have Industry 4.0. This is one important point to get Industry 4.0. And this is what we have here.
Okay. Okay, so we'll be around here after as well for questions.
Yep.
I think you'll be more important for answering those questions than I will be. But please, inside the Q&A that you'll see on the screen that you're on now, just write any questions in there. We don't have the chance to allow you to talk to us, but by all means, type it in there, and we'll get through to the questions as they come through.
Mm-hmm.
Okay, so we'll leave it at that for now. I
Yep.
think we'll let the video talk for itself, and we'll be back here in about 12 minutes, I think.
12 minutes, yeah. Okay,
Start
see you
counting.
then. Yeah. Now we are here at our Lucas-Nuelle Industry 4.0 production line. I want to show you what we want to do here and why we can call it Industry 4.0. But first, I want to show you what we want to do. We want to produce here workpieces with 3 parts. We have the bottom part, the top part, and the bolt. Every part we have in 2 different variations: black or white, and here plastic or metal. That means we have 8 different combinations for the workpiece, for the full workpiece with the bolt. Another possibility is for the second product that we only have the bottom and the top part in 4 different combinations. 2 products in 12 combinations. And this is what we want to produce here. How to produce it? We have here our workstations, our IMS workstations. Here one workstation for the black bottom parts, for the white bottom parts. There the 2 stations for the top parts and 2 stations for the bolts. When the workpiece is produced completely, then the robot takes the complete workpiece and put it here into this station. This is our testing station. And here we do the quality control with some sensors which are here in this station. After testing the workpiece, the robot takes the workpiece again, put it back to the production line, and the handling station takes the workpiece out and bring it here, and then the complete workpiece is here. Where we can produce it? We produce it here on these carriers. These carriers are here in the production line, and on these carriers we produce then the workpiece. All the carriers have an RFID tag inside, and to read the identifier of the RFID tags, we have in every conveyor belt here in the station, in the production line, an RFID reader and writer head with I/O link. In every conveyor belt we have a PLC and an I/O link master. And at this I/O link master, the RFID I/O link reader is connected. And this is what we want to do now. We want to produce. But how? Normally in Industry 3.0 it is possible to produce only with the help of the PLCs. The PLCs could manage here everything. But this is not what we do here. We have also here an ERP system, our ERP lab. And this ERP system has also an MES inside. And this MES controls here the production, not the PLCs itself. The MES controls everything. And this is also a reason why we can call it Industry 4.0, because everything is networked together up to the ERP system. And this is what I want to do now. I want to create now an order with our web shop, which is also included in our ERP lab. And then if I order now 1 or 2 workpieces, then we can also have a look at our SCADA system, and we can see what happens here in the production line live. And this is what I want to show now. First I put in the other carrier which I had in my hands, and now I want to go to the web shop and I want to start my order. So I choose here the workpiece, the product I want to have. I choose the product with the bolt, and I choose, for example, a white bottom part, a black top part, and a plastic bolt. Add this to my cart, and then a second possibility, for example, I change only black and white, add also to the cart, and now I go to the checkout and I can create now a new account, or I make a guest checkout, my personal data, continue the delivery, the payment, everything like you know it from every online web shop in the internet. And this is also what we do here. Then we have here an overview about our order, and I can click here now on confirm order. And if I click on confirm order, the order is now saved in the ERP system, and the ERP moves it to the MES, and the MES controls now the production. First, what I ordered was a white bottom part and a black top part. This we have now here. And to complete the workpiece, I ordered also a plastic bolt. And this plastic bolt is now pressed into the workpiece. And now the robot starts to move, takes the workpiece, the complete workpiece, bring it here to the testing station, and we do here now the quality control. So with the help of the sensors, we know now that this workpiece is like we ordered it, and the result of what we ordered and what we tested, the result we can see directly also in the touch panel. With the second workpiece, this is what we can see then in the touch panel when it is checked. And now in the touch panel we see the workpiece we ordered and the workpiece we checked here with the testing station. And now complete, and the robot puts it back to the production line. Now the trainees, imagine now I'm a teacher and I say to my students or the trainees, please program it. So that's not that easy to program it at once. That's the reason why we designed it modular. That means we can separate here the complete production line to single modules. And this is what I want to show now. So I separate first the curve, and I can separate also here the conveyor belts with the stations. But how to program it now? In the first step, we program not the conveyor belt in combination with the station. We start to program only the conveyor belt. Move right, move left, hardware configuration, move in different speeds, and so on. So you can do a lot only with a conveyor belt. All the projects are described in our LabSoft courses. That means the students or the trainees have a LabSoft course, and then they can read all information they need to program the conveyor belts, and all projects are described there. How to go on? We can go on if, for example, we connect a second conveyor belt and then do the network between two conveyor belts, that we have then a Profinet connection between the master and the I/O device. Or what we can do also is when we programmed the single conveyor belt, that we do in the next step the programming of the station. That we do a sequence programming in combination conveyor belt and station. Or the third possibility is that we connect to our conveyor belt directly our ERP lab. That the conveyor belt is connected with our MES and ERP system. That you can learn how to do Industry 4.0 programming only with one conveyor belt. It's not necessary to have the complete production line. You can learn it also with one conveyor belt. And this is our concept, what we have here, the modularity of our complete system. What can we do also? We have also here inside our AR, augmented reality, is also one topic what we have here in our system. And this is what I want to show you now. So I put everything together again. So the station is already connected to the production line, and I also created now an order again. And now I want to show our augmented reality, and this you can see here that we see here our live data from the stations. That means now when the carrier comes to this station, then we can see here in live all the signals of the station, and also when the conveyor belt is running, we can see it here in augmented reality. All the signals you can define by yourself. Everything is free configurable. That means you can configure all the sensors and actuators, and then you can see the signals here live. And you can also position the sensors where you want to have it in augmented reality. All the signals you see in the AR app we get from the PLC directly via Wi-Fi. So the tablet, the app, is connected via Wi-Fi with the PLCs, and then we can control and check all the signals of the PLC. So that's it for the Industry 4.0 production line. And for further information, you can have a look then at our homepage, and there you will find all information we also had shown here. So thank you very much. Yep.
Welcome back.
Welcome.
Okay, so this here is one of the little fixing points that you were talking about in the app there.
Correct.
So that comes, how do you get that? Is that something you purchase when you get one of these systems, or is that, do you download that from the App Store as well?
Download from the App Store. Good idea.
3D printed?
Yes. No, you can, the app is completely free. You can download the app from the App Store or from the Google Play Store. But if you want to use the full functions of the app, then you also need this here, this fixing point. And this fixing point you get if you have our course. Now, for the app, we also have a course where everything is described, also the fundamentals about augmented reality.
The ILA course.
The ILA
the LabSoft
course.
Environment with the...
Yes,
yeah, okay.
Correct. And everything is described there. Also, the connection is described there. How to use the app, how to connect the app to a PLC. This is everything described. Okay. And then you also get this fixing point with the course. And this fixing point is also what you need if you want to use the app also in augmented reality.
But you need a pretty late model phone with the AR core inside
AR
of it.
core, that's very important, AR core. So your mobile
won't work
device...
with your Nokia 3310? It won't work with your Nokia 3310.
You can try it, but I don't think that it will run. Yeah,
Okay.
no. So what you need is a mobile phone or a tablet which has the AR core. That must be included in your mobile device, and it could be iPhone, iPad,
Android.
or an Android system. It doesn't matter. So if you look for IMS Factory in the App Store, then you will find it. You can download it and you can use it for free. But if you want to use the AR functionality, then you use also this fixing point for the app.
Okay, and that just fits under one of the legs of the
Yes,
unit
correct.
here, for example.
Yeah,
And,
here it's not that easy because this one is fixed, so it's not possible. Yeah, just put it here in front of the conveyor belt, and then you have the fixing point here, and all the signals what you have seen in the video are the positions of these signals are relative to this fixing point. And what you see there is the direct information. So the signals of the PLC you see then in augmented reality, and that's brand new. So we have several solutions for AR on the market, but the solutions you find on the market are only that you have a sticker on the machine with a QR code, then you can scan the QR code and then you see the 3D model of this here, or any PDF will open and that's it. And then
it's more of a trick than
it's more a trick. Yeah, it's a gimmick.
Actually,
it's not really augmented reality. So
so I think
like
the
this
application that you're trying to show here would be for like predictive maintenance, for example, where you can see the status of the various machines that you're looking at. So
yeah.
We've seen some of the in actual operation, you can see the technician having a look at the entire factory floor, and you can see what's wrong with any of the machines.
Yes. And it doesn't matter where you are in the machine at this moment, because normally when you have a real production line like in the industry, then you don't have a production line with 3.5 meters, then you have 350 meters or bigger, and then you can't go with your tablet through the machine and see everything at the same time. So that's the reason why we have also signals in the AR lab, in the AR lab, yes, that you have a pop-up signal, yeah, that you see, oh, there's an error inside the machine ABC, where, no, and then you go there to the machine with a tablet, and then you can see, that's the error, and then I can repair it. Yeah.
So if you're looking at the old way of a technician, they would still see somewhere on a computer interface that machine number 1, 2, 3, 4 has a problem, but then they go out into the factory and go, okay, where is that machine?
Yeah.
So here you can literally scan it, and it'll be like a flashing light or that pop-up, as you say.
Additionally, yeah,
telling you exactly where it is, so saving time.
Yes.
So this is not, it's not just something fun to have, it's actually what we're seeing in industry, isn't it?
It's the future of the industry.
Yeah.
Yeah.
Absolutely.
And this is what you need for the industry, and also the knowledge is what you need.
It's giving you that experience that you need. So, and that's again the Lucas-Nuelle philosophy in everything we do. It gives you working through the fundamentals, and that's something else that we don't have here. We can say this is the top of the line when it comes to
correct.
Who is it, by the way? Who would be working on this? Is it apprentices? Someone doing a dual apprenticeship or dual training, or is it someone studying at university?
It is for all.
Okay.
For all, because you can use this system for the fundamentals to learn how to program a PLC. Then you go a step further, that you connect more PLCs together, and then one step further is that you connect the MES and ERP system, and that's the higher level also for universities.
Okay.
Yeah, so you can use this system for all levels.
Okay, fantastic. And even at the introductory levels, you have a whole range of products for Unitrain, for example. I think you've developed a PLC, your own PLC for Unitrain,
Yes,
with the different
correct.
systems. Even if it's hydraulics, pneumatics, electrical, there's all of those stages that you get to before you get to this.
Yes, correct. Yeah,
okay,
that's true. Yeah.
Fantastic. Okay, so we've got a question come through now. So, when comparing LN system to Festo Didactic, CP Lab, or NCON i4 systems, what are the differences between the systems? Do you know NCON? I don't know that one myself, but...
Show me how it is written. Yeah. Okay. So the CP Lab from Festo here. Okay, there are some differences between these systems, but I think now it's a little bit too much to talk now about it. So I think that's a really special question, and I think we will answer it later. Yeah.
Okay.
And we will write the answer.
So get in contact with us. You have our email addresses on the presenter, on the registration form. Drop us a line and we can get into a bit more detail about it if required. And obviously, Festo is a large company. They have systems. There's, but this is something else that we're very proud of that fits together. And as you said, seems to work really well for training purposes.
Yes. Yeah.
Where are some of these systems? So I know that every time you sell one of these, you always get it operational here in the factory. Make sure everything's working, get it all set up before it gets sent away to the country. So what are some of the countries that where you've set this up, for example, like the complete system, literally all around the world?
All around the world. So in Asia, here in Europe, in a lot of countries, and also in the US, we sell it and run this system. So there are a couple of systems we sell and send all over the world. So I don't know how many of these systems we sell up to now, but there are a lot of systems.
Okay. Yeah. And it's many different configurations as well, right? You've got the robot here, but I've seen you've often have a like a lathe or a milling machine here where the robot can produce. What does it produce? The little bolts, is that correct? That you have
with the lathe machine, we produce here the bolts, like this here, for this station, the small bolts, and with a turning machine, and with the lathe machine.
The lathe, yeah.
Yes. And what we can also produce are the bottom parts of the workpiece. So this is also what we can produce then, correct? And it is also possible to make a combination here between a robot and these machines. But not here with a universal robot. For this, we have other robots like the KUKA robot or a bigger universal robot, and then
so that's the real one that you see in factories, for example. KUKA, big orange one that you see everywhere.
Yeah, this you have nearly everywhere around the world, the KUKA robots. Yeah, but the difference is this here is a collab robot. Yeah, there's no need for safety around it. But if you use the KUKA robot, of course, then you need safety around. Yeah? So the working space has to be saved. Yeah.
So this one you were telling me, you can literally, in training mode, is it for the robot, you can move it to, if you need it to do a function from there to there, you literally pick it up and close it and move it. And
correct. So not only by pressing the buttons of the control panel, you can press one button and then take the robot arm, position it where you want to have it, save this position and the next one, and then it goes.
Okay. Okay. So you also said one time there's 3D printing.
Yes, yeah.
So
So
the
we
ability to...
have a lot of additions. A lot of devices we can add to this Industry 4.0, and this is also how we develop our new devices. Is that we want the devices to be able to add to the system. So, for example, a manual workbench or a 3D printer or the lathe machine and so on. So everything is possible to add to the Industry 4.0.
The manual workbench is something interesting. So that's essentially being able to build the same components, but manually.
Manually, yeah.
But it's guided. So you
Yes.
have a table which kind of tells the person, okay, you need to take this component now, add it here. And I think there's even, it shows you, is there some sort of...
it shows you...
with a projector?
With a projector, it shows you how to set it up. And by pick by light, you will get the information where to pick the next part. And with the projector, it is shown how to set it up. And that's the manual workbench. And also this is connected to our ERP lab. Our ERP lab is also controlling this system, this manual workbench. So the ERP lab, we can also talk about the ERP lab. Our ERP system is not an industrial ERP system, because industrial ERP systems are often very complicated. You need so much time to learn how to control this ERP system.
You need a team of specialists just to get that created, basically.
First, you need minimum 2 weeks training to get an idea how to run the system, how to control it. But then to make a connection between this industrial ERP system to the machine, there's nearly no chance. So for the connection, you need the MES. This is what I said before. You need this MES. And in our ERP lab, that's a didactic ERP system. There we have also the MES. We have a SCADA system to see live what happens in the machine, and also the web shop to create the orders.
Okay. We've been seen in, I think you told me about it on a separate occasion, about the ERP can even do the ordering. So for example, of the raw materials. So you can even create that as well to kind of get, again, that whole work process needed for the people who need to understand these things.
It's also like with a 3D printer. So it's not only possible to make to create the orders for the for the work pieces here, like with the bottom, top part, and the bolt. It is also possible to connect the 3D printer to the ERP lab, and then you can order some 3D models. And if you start the order, if you create the order, then this order is saved in the ERP system, and then the MES controls the 3D printer, and the printer starts to produce what you ordered.
Okay. So we've got getting quite a few questions coming in now.
Very nice.
One from Nenan. Greetings to both of the gentlemen. Greetings
back.
Thanks for joining us. Mr. Naglick, can I get your email address? I have some more questions concerning our collaboration. Now, he's put his email address there, so we'll pass that on if you're happy. I'm sure you're more than happy to talk about that. And
no problem.
We'll send you an email, absolutely.
Okay, no problem.
Okay, a question from Nolan. Hello,
Hi,
Nolan.
Nolan.
If the PLC is not visible in the augmented reality, can the status be called up in the app?
Yes, you will get a status. The status is there's no possibility to make the connection to the PLC. That's the status then. So, and if you can't get a connection to the PLC, then you have to check the Wi-Fi. You have to have a connection via Wi-Fi with the PLC. So the PLC is connected via normal Ethernet cable to a Wi-Fi device, create a Wi-Fi, and then connect your mobile device via Wi-Fi with this one. And then you need the correct IP address. The IP address of the PLC, you have to type in the app, in the configuration of the PLC, and then you can get the connection to the PLC.
Okay.
That's it. So very, very easy.
Very easy. And again, it's explained in the ILA course.
Yes, in the ILA course is everything explained. Yeah.
Okay. Did have a question, it fell out of my head, so we'll go to the next question. What happens when any product is not passed green by sensors? Total conveyor line will stop, or are there some other way?
Didn't get it. Again, please.
What if one of the sensors is faulty? Will the system shut down? So it depends on the fault that you have, I assume.
Yeah, it depends on the fault. So you get also such error messages in the ERP lab, so in the SCADA overview. So if one sensor doesn't work anymore, then you won't get any signal back from the carrier, and then the system stops. And then the system gives you back a signal or a message that this sensor doesn't work anymore.
Okay.
So that's how it works now.
What do you have for fault finding in the system? Do you have any faults that you can the teacher can switch on or off, or?
So there are unlimited faults you can set. So especially if you add the factory app, then you can define any error you want.
Okay.
Any error message you want, you can add. So because in the factory app, everything is possible to configure like you want it.
And I've even seen on the app you can control each of the systems backwards, forwards. So remote control all of the systems as well.
You can also control the system, or you get information back about the sensors and also about error messages or something else. Yeah.
Okay. Damien wants to know about our friend here, Cactus. Is he a part of the system?
Yes.
He's been following us from all of the webinars this year, actually. So we did want to have him take a ride on the robot, but we found out the robot was actually a little bit too loud for our microphone. So we thought he'd just sit here in between us. Okay, what is the future for IMS Virtual? Will it also be updated to include newer components?
Yes, it will be upgraded within the next within the next year. So this is the plan to upgrade it.
Can you maybe tell us what IMS Virtual is for the people who don't know that?
For the people who don't know, so IMS Virtual is our 3D model or our 3D virtual world for our IMS, for our industrial mechatronic system. So, and in this virtual world, you can also program this IMS. That means you program in the TIA portal to program the PLCs. Then you can start on the computer the virtual PLC, the PLC simulation, and then you can upload your PLC project to the PLC simulation, and this PLC simulation communicates with the IMS Virtual and controls the system. So everything what you have seen in the video, so how the system runs, you can also run only on the computer. So you can program the PLCs and run the system on the computer.
And you see all of the components in 3D, like just here, but it's occurring on the screen, so you can
Yes.
see if there's any conflicts with the different materials going on. It's something very common in industry, is from what I understand as well. They always run everything in simulation first to make sure. It's obviously much cheaper to smash a robot in simulation mode than to do it in real life.
Yeah, correct. Yeah.
Okay.
What you check there is the sequence programming, the sequence to program the station. This is what you learn there in this IMS virtual. Yeah.
Okay. So how many students would you normally see on a system like this? I think you've told me in the past that the students would actually start working on one section like this on their table on their own, connected, and then start working. How does the conveyor belt work? Different programming languages, or what's this PLC? Different protocols, different buses. It's really got almost every different type of system on there, if I'm not mistaken, right? Yeah.
So at this system, we have here 8 of these conveyor belts. So if you add this here with a robot and this station, then you have 9 conveyor belts. So you have.
They're all the same. Each of the conveyors is exactly the same.
Each of the conveyors are the same. Don't know if you can see it. No. A little bit here.
Can you just move that down for us, please?
Move down a little bit the camera. This conveyor belt here. So this conveyor belt is exactly the same here, like in the production line. We have here 8 times. Additionally, with this one, we have it 9 times, and then you have 9 stations and you can work in 9 stations at the same time. That means at one station, maybe 1 or 2 students can work with it at the same time. So more than 2 is not that nice, because then often one student sit there and do nothing. That's the normal way. Maximum of 2 students at the same time at one station, at one conveyor belt. And then these 8 or 9 stations at the same time, a little bit more here, and very important, this one,
Go for a ride.
Go for a ride. And these 8 or 9 stations at the same time means 16 or 18 students at the same time can work with this system, and they can connect also a separate conveyor belt with the ERP system. So there's no need to program the complete production line first before you start to connect with an MES and ERP system. You can also do it with a separate conveyor belt. So that's very important to know, that you have then 8 or 9 stations at the same time, and every station is communicating directly with the ERP system at the same time. So you have 9 productions and not only one production.
Okay,
here.
wow.
Yeah.
Cool. Okay, we've got a question from Maximilian. Can Industry 4.0 work with other systems instead of PLCs? I guess PLC is kind of the basis of...
Okay, the PLC is one part of the Industry 4.0, but there are also other devices you need to get Industry 4.0. Let's think about the IoT, Internet of Things. So every device which has a connection to the internet, with an Ethernet port, then you can connect it with the cloud system, and also connect with an ERP system. So if you have any other machine which has an Ethernet port, then you can also get there Industry 4.0. It's also possible.
There's nothing out there that replaces the PLC. There's no other. That's kind of the basis for the controlling, isn't it?
Yeah. So to control this system here, this station here, for this we need the PLC. Yeah. And then the connection between the PLC and the ERP system is then here in this production line our Industry 4.0
Okay.
idea. Yeah.
Okay. Paul has noticed that there's something new on these conveyor systems there. He said, can you define CPS and how the term applies to LN hardware? So
okay,
down here, there's a new sign on these conveyor systems.
Yeah. CPS, you know what it means?
Cyber physical systems.
Very good.
Yeah.
So cyber physical system, that's also a new word which comes with Industry 4.0 or with a smart factory, the cyber physical system. So how is a cyber physical system defined? A cyber physical system exists of 3 parts. We have the mechanical part with sensors and actuators, and here the mechanical part. Yeah. And then we have also a microcontroller in it. A microcontroller here, the PLC. And the third part you need for CPS is the connection to the internet. And this we also have here at this conveyor belt with the Ethernet ports. So these 3 parts you need in one device to have a real CPS. Then you can call it CPS. But it is a must to have it in one device. Yeah? The mechanical part, microcontroller, and connection to internet.
Was that the first system to have that CPS available on the market? Did you?
This one?
Yeah.
No.
As training, though.
As a training system?
Absolutely.
Yes. Yeah. But not the first.
Absolutely, no.
Yes, but as a training system, in this way, it was the first on the market. Yes.
Okay.
Correct. The others are copies.
Of course.
Yes.
So the term cyber brings in some questions, of course. So cyber security, is that somehow addressed, say, in the LabSoft courses or ILA for Industry 4.0?
Yeah. Cyber security is a very important topic also in Industry 4.0, because all data you send via internet to the cloud. So you have to save your production, your production line, your hardware. You have to save the hardware. And that's the reason why we also have here a cyber security course inside, and also the cyber security hardware. So that means we defined firewalls that it is not possible to attack the hardware from outside, but it is still possible to see all information about the orders. When will my product be delivered to me? This I can see via internet, but it's not possible to attack.
Okay.
To attack the hardware. It's protected by the cyber security.
Okay.
But how to do this? How to make these firewalls? This is everything also explained in our ILA course. So these courses we have for all the hardware you see here. We have a course for the conveyor belt. We have courses for the stations, for the robot, for cyber security, for all topics we have here. We have also the courses.
Okay, fantastic. Well, we don't have any more questions come in now.
Oh, no more questions. So
yeah. Okay.
Okay.
I think we've covered it then.
Yeah. So then we will explain everything when no more questions there are.
You're all experts on Industry 4.0 now?
Yes. Correct.
Marijan, thank you very much.
Thank you too.
Enjoy the rest of the day. And but we'll be here for a few more minutes. So if you think of something after we turn the cameras off, don't worry, we'll still be here.
Yeah.
And if you think of something tomorrow, you've got a hold of our email addresses. Just reply to the emails that you get for the registration. They'll come back through to us, and we'd be more than happy to answer anything you might have.
Mm-hmm.
Okay.
Okay.
Thanks very much. Enjoy the rest
Thank
of the
you.
day wherever you are.
See you i do widzenia.
Dobro dzień.
Do widzenia.
Dobro dzień. See you later.
See you. Bye.